Hello guys, in this video I will explain you about stages in Spark. So what is stages? Before going into that section, we will understand how many ways we can write our Spark code. We can write our Spark code using Scala, and also we can write our Spark code with Python, and we call that as a Pyspark. Now come to the stages. Remember these 2 points, okay? It will be very useful in later part of video. Now stages is a like boundary. So what is stages? Stages are boundary marked by shuffling. Shuffling means data shuffling. Okay, shuffling. Remember this part. The stages are boundary marked by shuffling. At this point, you will not be able to understand what I am trying to say. So that's why let me show you the code. Okay, so in previous video we wrote one code, Pyspark code. Okay, I will show you what is that. So if you go to my playlist, this is the lecture number 18, convert data to RDD using Pyspark. In this video I wrote one Pyspark code, and we'll take that code and we'll try to, and I will explain stages according to this code. So let me show that code. So this is the code. So what is the problem statement of this code? We have one data inside a list. We have to convert this data into RDD, and after that we have to find the number of errors and number of one present in this data set. So first we have to convert the data into RDD, and then we have to find the occurrence of error and one for from that RDD. How we can do that? So for doing that, we are importing Spark context here. Then we are importing this. This is to take system input, okay? And then we are creating the object of Spark context. Then we are setting the log level. This is our data. We are passing this data to this parallelized function. It will try to distribute our data in multiple nodes. Okay, then this will create one RDD, and on top of RDD we are trying to apply map function, and we are passing this, we are passing this lambda function inside the map, and this lambda function will try to fetch each record and try to split this each record, and using this colon separator, and from there we are trying to take this index 0, means error 1 index. We are trying to accessing this index 0 means error 1 and error 1, these things, and try to map with 1, and then we are trying to use reduce by key. So I already explained this about this code in my previous video. You can watch this video, okay, to better understanding of the code. Now what actually we're trying to do here, then we are trying to do the collect operation, like action. This is a color action. Then we are trying to print it. Then we are doing stdin.readline. What is the meaning of this? We are saying that until we give output, just hold on this program. Don't end this code. Okay. So Spark engine will try to hold this program. Okay. Why we are doing this? If we want to see the DAG, then we have to hold our code, hold our program. If we are not holding our code, then we cannot see DAGs. Okay. So in this you can see in this code we are using one map here. Map is narrow transformation. Okay, map is a narrow transformation, and this reduced by key is another transformation. This is a wide transformation. So in our code we are using one narrow transformation. Let me write here one narrow transformation, map parallelize, that also you can say transformation, and one wide transformation is, so two narrow transformation and a wide transformation, and one wide transformation, that is our group by key, group by key function. Sorry, so this is admitting some water. So in our code we are using this two narrow transformation and one wide transformation. Okay, this one you can treat as a transformation. Narrow, this is a narrow, map is narrow, and this is the wide transformation, and this is the action. Now, if we run this code, if I rerun this code, and observe that our logs here, see, it is setting the logs. Then it is saying the Spark UI could not bind 404 to attempt to port 4041. So if I want to, if we want to see the DAG, direct acyclic graph, which will represent the execution graph of RDD, it means Spark will follow this DAG diagram to execute our code. Means it will follow that, after which RDD, like the DAG will be like this: RDD1, then RDD2, and RDD3. It will say that it will convey to our Spark engine that after RDD1 it will say that on top of RDD1 you have to apply map. Then then we will get RDD2. After, on top of this RDD2, we have to apply group by key. Like this, it will maintain some graph, and according to that graph, Spark engine will understand what we have to do. What should be the next step for Spark engine to execute our code. Completed it. So DAG is like this. To see these DAGs, we have to go to this. Okay. By default, if we go to localhost 404, we can see the DAGs. But now it is saying that we cannot bind it because there is some another service which is going on this port. So trying to port 4041. So now we can see our DAGs in this 4041. If we go to my browser, see, if you type, if localhost 4041, we can see our DAGs. Complete these jobs. So this is our DAGs. Okay, you can see DAG visualization. And inside this DAG, if we drop down, if we click on this DAG visualization, inside this DAG here, you can see we are using this parallelize function. Then it is under stage 0. Then it is partition by map partition, and it is answered stage 1. But in our code, we are not using this partition by partition, map partition, but Pyspark intelligently doing some operation. Okay. Now just hold on. So we wrote this code using Pyspark. Now we'll using Python. Now we'll try to write this code using Scala, same code using Scala, and we'll try to execute that. So I'm coming to my Scala ID. This is my Scala ID. Same code. Also, to write Spark code in Scala, we have to import some library. Okay, so we are trying to import the Spark context in this logger and log for this level. So we have to basic part. We have to, like in Java, we have to import some library when you're trying to write some code. Same like this in Scala also, you have to import the library. Okay, like what we are doing in Python, import Spark context, we are doing this like this. We have to import there also. So we are trying to this from org Apache Spark. We are trying to import Spark context, and we will take this Apache 4G logger. It will try to set this library needed to set the logs. Logs mean log level, means in Python we are trying to set log levels like this: info, error, if you observe my playlist, you can easily understand what I am trying to say. Like we can set different type of logs here, info, error, warning. Like this, to do this kind of thing, we have to import this library in Spark. Okay, so now we are doing what we are doing. We are created one object here. So if we go to file and new, then you have to just create this Scala object. If you create Scala object, it will give some interface like error count, object error count. It will give like this. Now what we are doing, we are trying to extend app, because extend app means it will try to inherit one main method. To execute any Scala code, you need a main method. To get a main method, you can write main method manually, or you can extend this app. It will try to automatically inherit that main method. So you don't have to write it. Now we are setting the log label here. Set get logger org set log label label.error. It means I need those logs. If we get some errors, we need those logs inside this console. Then we are creating variable here, object of this Spark context, local star error count is the name of this job, and we are assigning to the SC. Then this is our data. It is under the list. So in Spark we have to list, the data will be in first bracket. That's how you do in Scala. In Python we use this square bracket, but here we use this first bracket. Now what we are doing, we are trying to do sc.parallelize, same like Python. Here also you can see we are doing sc.parallelize. Okay, and passing the data. In Scala also we are doing this. Then what we'll do, we are trying to using map function here, editor map, and this is a lambda function. It is what it is doing. This lambda function will take every row as a string and try to split it according to this delimiter, and it will try to, after splitting this each record will be converted into a list. It will try to access the first index. Okay, it will try to access the first index. First index means error 1, this and comma 1. Okay, and then we are trying to assign 1 to every error, every key, like error 1. It will do after the completion of this. IDD2 will hold information like this: error 1, error comma 1, error 1 comma 1, 1 comma 1, error comma 1. So we are trying to assign map 1 to every key value. Okay, every key. Those are key. I need those information because we have to find the occurrence of 1 and error. Now we are using reduce by key. This is the lambda function. How you have to write x comma y or something, a comma b, and then you are doing this x plus y. It will try to like add those things. Try to like add value of same key. Similarly, what we are doing in here, we are using lambda like this. In Python we use lambda keyword, but in Scala we don't use this lambda keyword. We have to do like this. Now we are trying to do, we are doing the identity.collect means we are trying to apply action. Then we are we are using for each loop to print the content of this identity, and after that we are doing scala.io.std and return. It means we are holding our Scala's code. We are saying that until we get some input from our side, just don't execute, don't end this code, because if we want to see our DAG, we have to hold our code. We have to put our job in a holding position. We should keep running our jobs. Okay, that's why we are doing like this. So this, if we hover on this red button, it is saying terminate, because this job is still going on. Okay, now to see the DAG of this Scala of this, to see the uh, mm, DAG of this job, what of this Spark job. This Spark job is written in Scala. Now we'll see the DAG of this job. Okay, the job name is, you can see error count. Okay, observe this. We'll go here, we'll come to here. Now you can see here localhost 40404040, and the job name you can see here, error count. Okay, error count, collected error count, collected count. And if we go in the next tab, here Pyspark code, and here the job name is count error, count error. Okay, we go here, this is the count error. Okay, now what I'm trying to say, see, for same code, for same logic, the DAG of this, you can see inside stage 0 we have a parallelize and map, then this reduced by key, and here for same code we have a parallelize, then partition by, then map partition. So you can see some different DAG for same code, but differentiated is here, we are writing one code using Python and we are writing one code using Scala. So what I'm trying to say, for same code, for same logic, same logic we wrote using two languages. Okay, one is Python, one is same logic we write this logic using Python, we wrote this logic using Python and Scala. So same logic, same logic, same code, but we using different programming language. But for same logic we are able to see that there is some DAG difference. Okay, there will be difference in DAG because the Scala, the Spark engine is by default written in Scala. Okay, so those Spark engine is implemented by Scala. Okay, so when you are writing some code directly, when you are writing some code in Scala, so Spark engine can easy to map it, because Spark engine is also written by Scala and our programming code is also Scala. So it will try, you can easily convert our code. Okay, but what will happen, but when you are writing code in Python, that time it will be problematic, because our Spark engine is Scala. If our Spark engine is implemented by Scala, if our programming code, like we are writing our job using Scala, then it will be easy. Okay, it can easily understand. But in our scenario, the Spark engine is written by Scala, but our jobs code, what we are writing in our IDE, that is Python. Okay, that time the Spark engine will not able to understand the Python code, because it is implemented by Spark. So there inside mediatory point there will be an API, some Python API will be there, Pyspark API will be there, which will try to convert our Python code into Scala's code. Okay, so that the Spark engine can understand. Okay, so see the difference. Here Scala's code directly executed by our Spark engine, but here our Python code is, first will go to Pyspark API, then it will go to Spark engine. So there is some difference in the process of execution when you are writing in Pyspark. That's why we can observe that for same logic, for same code, we have this is the Pyspark code. See, the DAG is like this. In stage 0 we have this and this. If we go here for Scala, this is the Pyspark, and if we go here in previous tab, this is for Scala. You can see from inside stage 0 we have this parallelized function, map function, and inside stage 1 we have a reduced by key. So there is a difference. And what is the difference? You know, because in Python there is a difference between execution process. Scala code can directly communicate with our Spark engine, but Python code cannot. Pyspark code cannot directly communicate with our Spark engine. So there is a one Pyspark API. So our Python code will go to Pyspark API. First, it will go to Pyspark API. Then Pyspark API will forward to that Spark engine. So there is some intermediate. There is some execution difference. There is some execution difference when you are writing code in Scala and Python. So that's why we are getting different type of DAG. And one thing I want to say, and this difference, no? So the conclusion is there will be difference in DAG. So let me write it. So conclusion is there will be difference in DAG for Python and Scala when we are working on top of RDD. Okay, when we are working on top of RDD, because if you see our code, every time we are saying RDD1, RDD3, we are working on lower level. Okay, if you go to here also you are doing this bhal RDD1, bhal RDD2. This is RDD. When you are trying to playing with RDD, at that time we will see the difference in DAG diagram. Okay. But if we are working on data frame, that time we will not able to see any difference in DAG for Python and Scala. That time this problem will be resolved. But for this time it will be when you are working on lower data unit like RDD. Okay, this is the basic unit of Spark. When you are working on this lower level, we will see this problem. So there will be DAG difference in Spark and in Pyspark and Apache Spark. Pyspark means Python, using Python. Apache Spark means using Scala. So that's it. There, I think now it is clear why the DAG is different. Now we'll come to our real question. What is stages? So stages is boundary marked by shuffle. Shuffle means data movement. So if I try to simplify, shuffle means data movement. When data movement will happen? When there is a white transfer. So we can see stages in DAG diagram in DAG if there are white transformation. So what are the white transformation? Group by key, reduce by key. Okay, this is the thing. Okay, so when you are working with white transformation, we can see that stages in our DAG. So one thing, number of, so if we have 3 white transformation in our white transformation, in our code, then we should have then we should have four remember four stages. Okay, so if there is a two white transformation, we have three DAG. Three stages. Stages means one boundary. Okay, if we have a one white transformation, we have two stages. Why there is extra one stages? Because when we are not using any transformation, that time there will be one boundary present in our code. Now we'll see the practical example. Now we'll go to our DAG. You can see this is the our Scala. Okay, this is our Apache Spark with Scala. Because when we are working on RDD, and if you want to understand the RDD, the base thing is you should every time follow DAG of Scala's code. If you are trying to understand your code, your code means Scala's code or Pyspark code, you should follow the DAG of Scala's code. So when you're trying to understand any code, you should write your code in Scala and then execute it, and then open your localhost 404 and see the DAG. In that time, you can easily understand. But because for Pyspark, the DAG will be different from your code. You will write map, you will use map and group by key in your Pyspark code, but in DAG it will show some different thing, because the implementation of Pyspark is different. Okay, internal. That's why you will see some awkward DAG when you are working on RDD. So if you see the Scala DAG, we can see that we are using this parallelize function. You can see now we are using this parallelize function, and it is inside one DAG. Okay, inside one stage 0. This is the boundary. Okay, initially we have one boundary. We will have one boundary, because there is, so initially we have one boundary. In stage 0 we have this parallelize function. This is one transformation, one narrow transformation. Map, we are using map here, one narrow transformation. Okay, so these are our narrow transformation, so there is no data shuffling. Okay, now we are using this group reduce by key. When you are using reduce by key, there will be because reduce by key is a white transformation. When it is a white transformation, there will be data shuffling. I means data movement. So this data is from here to it is coming to here. So that's why we are creating another stage here. That's why we are saying that data, the stages is marked by data shuffling. The stages is marked by boundary, because when we have a data shuffling means white transformation, that time we will have one. We will have one extra boundary. So every time we are doing one white transformation, that will get one another boundary. So white transformation like reduce by key, group by key, we will create stages. Stages means boundary marked by boundary. Okay. Now we'll see the Pyspark code, and we'll see the Pyspark code, this code, and we'll try to see the Scala's DAG. Code is Pyspark Python, but DAG is we are taking the reference DAG of Scala. This is the Scala. Okay. Okay. Now see in our Pyspark code, we are using this parallelize function. This is the parallelize function because this is an arrow transformation. So there is no data shuffling. Then we are using map. Same thing we are doing with map. Then we are using reduce by key. This is our white transformation. That's why this data is going data is moving from map to here, this stage 0 to stage 1. Okay, then we are doing this collect operation, collect action. That's it. So you can see that what actually we are doing in code, we can see in the DAG, in Scala's DAGs. But if we go to move to Python's DAG, see it is different. So now this is our Python DAG, this is the Pyspark DAG, and this is our Pyspark code. Now we'll see our code. So, so initially we are using this map, this parallelize and map. Now if we go to DAG, it is okay. We are using parallelize function. Parallelize is a narrow transformation. But sorry, but then we are using map. But if we go there, there is no map. There is no map. So you cannot understand your Pyspark code. You cannot understand this Pyspark code using your Pyspark code DAG, because that will be different. So we are using map here, map here and narrow transformation, but we cannot see the map here. There's some map partition is there, but we are not using map partition here. And then after map we are using reduce by key. It will come here. There is no reduce by key, but in case of Scala's DAG, you can see there is reduce by key. But if you go to Pyspark DAG, there is no reduce by key. But we are getting this two stage 0, stage 1. Here also we are getting two stage 0, stage 1. That is there because we are using one white transformation. But DAG is different. So always remember, when you are working with RDD, when you are working with RDD, you should follow Scala's code DAG to proper understand code's flow. I can mean RDD's flow. So if you want to understand what is the flow of RDD after what is happening, then you have to convert your Pyspark code to Scala's code, and then you have to run this, and then you have to see that what is happening in the DAG, because in the DAG, because using this is the Scala, using Pyspark DAG you will not be able to understand. So that's it in this video. I hope you are now your picture of this DAG, this stage is different. Stages means if we have white transformation, that time we will get on another stage. Okay, here we are using this white transformation. That's why the data is moving from here to here. See this arrow, and we are getting different stage. So number of DAGs equal to number of white transformation equal to 1 plus white number of white transformation equal to number of 1 plus number of white transformation number of white 1 plus number of white transformation stages. So number of white transformation equal to number. So if there is 2 white transformation, there will be 1 plus 2. It means 3 stages. Okay. From beginning there will be 1 stages. So that is thing. So if you see our code, there is a only one reduce by key. It means one white transformation. For that reason, we have a stage 0, stage 1. So that's it in this video. I hope you able to understand what I am trying to explain you. I think there is no other video in YouTube which explaining this stage, this DAG in detailed manner. So for better understanding, I will suggest write some code. You write some code in Pyspark, write some code in DAG, and run those job parallelly. Okay, like what I'm doing. I'm running this Scala job from here and this Pyspark job from here, and try for same code. Okay, for same logic, and trying to understand what is the difference between DAG. You can do like this for your better understanding. So that's it in this video, and you can, if you are looking for this code, you will able to find this code in my GitHub account. GitHub repo. I'll drop my GitHub repo link in this video's description box. And also I try to copy paste this code in my description box. You can copy from there and you can try it by yourself. Thank you for watching this video. Bye. Now it is for 5 a.m. I have to go for sleep. So bye. If you like this video, just hit subscribe button, share with your friends. That's it. Have a good day.